Alrighty, okie dokie. We're going to look at dilations today, so we're kind of starting to do units on just similarity, and so we're going to start with just one of those things what we call dilations. Again, some of this might look familiar. Hopefully, just kind of extend this idea and help you guys understand this idea a little bit better. So dilations deal with what we call scale factors. When we dilate something, we're going to have some shape. So even if we had like a triangle, and then what we're going to do is either make this original triangle, it's like triangle A, B, and C. We're going to make it either bigger, which we call that an enlargement, or we're going to make it smaller, which we call a reduction. So if I had this triangle right here, this would be a reduction because it's smaller than the original. How we tell which one's the first one, which is the second one, just your normal one with the vertices is your beginning one, and then what they'll do is they'll put this little prime value right here to denote the next one. So that's A prime, B prime, and then C prime. All that means is that's the image after you've done the dilations on there. So again, this would be reducing it by some scale factor that you have there that's involved. So those are what we call scale factors, those reducing and enlarging here. We're going to use the letter K to denote our scale factors with similarity here. So if I go like K equals 5, or K equals 1/2, or K equals 3/4, or K equals 3, or K equals 5/3. These are all scale factors, meaning it's either we're gonna take this value and we're gonna take the sides and increase it by 5, or 1/2, or 3/4. We're gonna do whatever we're gonna do with that. So we can look at it a couple different ways. One thing we could do is measure the side length and then apply the factor and see how it makes that side length bigger. So if this is like 2 centimeters down here, if I was doing a scale factor of 5, I'd just go 2 times 5, and that would give me 10, and so that would be my dilation would go from 2 to 5, or 2 to 10 is what I would get from that, okay? Just a couple other general things before we look at problems is anything that's a number that is greater than 1 is an enlargement. So this would be an enlargement. And anything that is greater than 1 can't be equal to 1, but greater than 1. Okay, so also this one here would be an enlargement. And same with this bottom one, because 5/3 is bigger than 1. And then anything that is less than 1 is a reduction. So this would reduce here. It's going to make it smaller, obviously, reduce here as well. So we'll look at those, make sure you pay attention to that, and we're going to learn how to apply those, okay? So we're making objects. Now we're not moving them, we're not shifting them right now, we're just enlarging them and reducing them. Okay, so let's just use those ideas on a couple problems here. So first one, what is the scale factor here? So I've got my two figures here. I got my figure that this black one is the original, and then the blue one's the after image because of the prime values. So I can go about looking for the scale factor a couple different ways here. Obviously, we've got a reduction here, right? It's reduced here. So we reduce this. We need to know by how much. So there's a couple ways of doing this. I can either just, because this is on a coordinate plane, I can identify the point and divide. But probably the easiest thing to do would just be to say, okay, well, how long is this side length? One of the side lengths. So I just take that one, which is 1/2 a unit. And then we've got 2 right here. So I've got this again as 1/2, and this is at 2 units long. So what I want to do is I want to know, well, how did I get from 2 to 1/2? What did I have to times by to get to that value, or get to that value there? And so instead of sitting there thinking, some of them are pretty easy, you can look at it. Usually all I do is I take the post image and divide it by the pre-image side. So this would be 1/2 divided by 2. And that would give me 1/4. That would give me what my scale factor is at that point in time. Okay? This is what K is right here. So post by what the original image was, and you just divide those two. And that should give you what you need. Okay, let's look at another one. What's the scale factor of here? This one here. Again, I can look at the side length. I would count up the side length I can find. So, or again, you can just do a point. This one might be easier with a point. So let's just do that here. Again, this is going to reduce, if you guys can see that. Reduce, there's my prime value. So the blue one's the after image. I'm going to say, what is this point on the coordinate plane? So this point is 1, 2, 3, 4. 1, 2, 3, 4. So this point is -4, -4 over here. This point right here is -1, -1. And so what I want to know, again, that's that point right there. Just another way of looking at it. So you can do the side way, or you can do this point way. So I always take, again, the post image divided by the pre-image. So I'm just going to go -1 divided by, sorry, hold on. -1 divided by -4, which that's just going to give me, again, 1/4. Just happen to have the same value there, but it does give me a positive value. This would be my K value. Yes, you can write it as 0.25. It's the same idea, no problem. If you want to put it that way as well. So again, you can do it with the sides where you go the post image by the image, or you can do it again by points like we've got here. Again, either way works just fine. You also need to be able to apply a dilation. So to do this, I think the easiest thing is just to take each point and apply that. So I just identify where this point is. This point is at -1, and then 1, 2, 3, 4, 5. So this is -1, 5. This point is at 1, 2, 3, 4, 5. This point here is at 4, 0. And this point here is at 0, 2. And so if I'm going to apply a factor of 1/2, all I'm going to do is times both these by 1/2. So this point, I'm going to do these in blue. This point here, if I times -1 by 1/2, that becomes -1/2. And then 5 by 1/2, that becomes 2 and 1/2. So this point that's K is going to be at -1/2, and then 2 1/2, which is going to put it that point right there. Okay, so that is K prime. Okay, then if I look at this one again, if I times this by 1/2, that becomes 2, and this becomes 2 1/2. So if I go 2 and 2 1/2, that's going to be right here where I wrote that value there, and then I've got that line there. This point is Z prime. Okay, now let's do this point W. I've got 0, 2. That point, if I times that by 1/2, that still becomes 0, and then 1. And that's W prime, so 0, 1 is right here. And again, that is W prime. So these points can now join. And then I need to do this last point that's B at 4, 0, which is going to become 2, 0 when I times that by 1/2. So again, 2, 0 would be right here. And so then if you can draw straighter than me, that'd be fantastic. This would be B prime. So you're just taking that and multiplying it. That's how you apply those scale factors onto there and make it a dilation. Okay. Last question here that you kind of might see here, good one to apply is if I have a point T that's a vertex on a triangle, so that just means it's a point on the triangle, and point M is the image of T after the dilation. So this m should actually be here. That should be 2 dash, sorry, it shouldn't be here. This would be m is 2 comma 1.5. Okay, so that's point m is the image of t after the dilation. And we want to find our scale factor. So I always just take, again, the post image and divide it by the image. So this would be my x. I'd go, and you can do either one. I can go 2 divided by 4. Again, if you would have went 1.5 divided by 3, it would have given you the same thing because this is 1/2. Again, 1/2. That's my scale factor is 1/2. So this is another way about doing that. So, okay, so there's your stuff on dilations. Math 1 with Mummy out.